Awesome. So I'm Vipin Dule. I'm from Hyper-V team, and I'm here to share some details on Private Cloud Simulator. Private Cloud Simulator, or as we call it, PCS, is a common validation suite which we use internally to validate some large-scale virtualization scenarios. So in today's presentation, I will give you a brief overview of PCS. But before that, we will also talk about different test approaches we have so that we can set the context right on how we have evolved from traditional testing methodologies to PCS. And then we will have some Q&A session if you have any questions. So let's start with functional test. I think most of us in the room are aware of what a functional test is. It's a quick and efficient way to validate an application's stability and its functionality. Advantage, it's predictable, it's repeatable. And if you hit an issue, it's easy to repro. It typically consists of small units of test where for each test, you will prepare a setup, execute the test, clean up, and then repeat the same set of steps. But as your application lighten up new scenarios, you have to add more functional tests. As your application grows more complex, your functional tests become more complex. So functional test is great as long as your application is small, but as your application evolves, maybe it's time to look toward other test approaches. So next strategy is model-based testing. So in model-based testing, we generate software tests using models of system requirement and behavior. We typically have small tests. We typically identify models an application will have, then convert them into test collateral, and then use this small test block to exercise big scenarios. We end up achieving diversity through randomization. But even in this approach, we don't typically have failure scenarios. And since operations do not necessarily talk to each other, so even if you have a big topology, even then these models have to avoid each other, leading to inefficiencies. Next approach is cloud scale, in which you have distributed models. So here the models are intelligent enough to talk to each other. They can communicate among each other. They can share intent. They can share their compatibility information. And operations can span across cloud. Now we can have failure scenarios. We can try out both sunny day scenarios, both failure mode scenarios. And we also eliminate a single point of failure. So with that, let's move on to PCS. So if I have to describe the PCS goal in one line, I would say that our goal is to simulate customer data center at a cloud scale. So we do this by setting up a private cloud where we have virtual roles and we have workload running inside the virtual VMs, virtual machines, exercising compute and storage resources. We perform both sunny day scenarios where everything runs smoothly, and we also try out failure mode scenarios. So it's not like we have a data center operations running and we also try failure scenarios. We have been using this tool internally as a common validation suite to validate a lot of cloud scale virtualization scenarios. This solution has been designed from scratch, keeping cloud in mind, and this solution can scale very well up to 64 and even more nodes. It has rich reporting, failure triaging inbuilt, which we will see in later slides, inbuilt into this. We have cloud level reporting with data being reported to us in real time. So here is a typical PCS topology. We start with having a couple of management node and private cloud simulator binaries run on the management node and drive traffic on the compute and the storage resources. We have a bunch of built-in data center operations which we will discuss. When the actions execute on the compute and the storage nodes, they will generate some logs, some data based on if they passed, if they passed or they failed, and the data is pushed to our SQL DBs. Our reporting module can look at this data, collate it, sanitize it, remove unnecessary noise, and then present to it on the web pages, which we will see in the later slides. Here is a sample list of data center operations we currently have. On the compute side, we have virtual machines running VM workload. We can have disk workload, we can have CPU workloads, memory workloads. We also perform live migrations of virtual machines. We also do storage migrations to simulate customer operations where typically in a data center you will see that they will be moving some VMs around, they will be moving storage to make sure that their load is evenly balanced across the cloud. We also have facility to try out drain evacuate scenarios to simulate operations where in a data center your data center administrator might be updating his host machine, updating OS, applying software patches, or there might be some hardware failures, so we have support for those cases. On the storage side, to keep things interesting, we have operations like CSV move. Wherever possible, we also try to enable data deduplications. So talking about some of the key features of PCS. The key feature of PCS is its configurability. PCS can be configured to run according to a customer profile for VMs and the operations. What it means is that you can choose and select the operations you want executed in your run, and you can also choose the frequency at which you want those operations to be executed across cloud. You also have the facility to configure and choose the VM configuration, the VM profile you want in your cloud. You might be interested in having a data center with high consolidation, or you might want VMs which are running heavy workload. We already have a collection of large operations which are already implemented, large models, which we talked about in the earlier slide. Another key piece we have in feature is resource management. We have a central resource management which knows all the resources which are participating in this run, and it's able to coordinate resource reservation between different actions. Also, the actions can talk to each other. They can negotiate resource reservations. They can negotiate, they can share their intent, they can share other information among each other. We also have this central resource manager is also responsible for doing resource validations. For example, if your one compute node goes down, you don't want to continue to run against this compute node. It will basically generate a lot of noise, which we don't want. Reporting. So reporting is again a key feature in PCS. As the actions, as the models we have, they continue to exercise resources in cloud, they generate a lot of data. And this data is pushed into our SQL DBs. This data is presented on the web pages live. So as your test continues to progress, you can go to your web page and actually see what is happening in real time. As failures or as success happens in the cloud, it gets reflected on the web page. Another common scenario when you are looking at a report is, okay, I have a failure. The next step is I want to figure out why it went wrong, or why did this feature didn't work. And then the next logical step is we look at the product logs, the related product logs. So we provide that facility in the PCS itself, where PCS, when it sees a failure, it will capture the predefined set of ETW channels you are interested in, and it will interleave along with the test logs. for efficient investigation. Also, PCS is intelligent enough to reduce unnecessary noise. It collates the failure across the cloud, it removes the duplicates, and shows only the top failures you are interested in, the ones you should investigate, put your resources on. Also, sometimes you might be interested in looking at what is the list of all the operations that happened on this particular resource, be it a VM or a compute node. So we also present that view. You can look at a resource, you have the entire history of that resource. You can see from the point it entered the test and the point at which it exited, all the operations which occurred on this resource. Along with this reporting, we also get monitoring out of the system. You can configure your cloud, you can configure the performance counter you are interested in collecting, and we will collect all those perf counters for you across the cloud, collate that data, and present it to you in a nice graphical manner. So here is a snapshot of the cloud monitoring picture. So we have two graphs, one showing storage IOPS, and the second which is showing the network utilization. So the first graph you see, it's not giving you data on a particular node, but it's capturing data from all the storage nodes you have, combining that data and presenting you a unified view so that you can look at this graph and figure out what is the effective IOP count you're getting from your storage subsystem. You can drill down to physical disk level. You can look at performance information of a particular virtual disk. So for example, in this slide, you can see that we are getting a consistent IOP of around 40K, and at this point there was a sudden dip, and then you can see that IOP count increased. So at this point, what happened in the background is a bunch of our VMs rebooted, so that's why you see the dip. And after they came back up again, we started storage migrations. That's why you see this IOPS count going up. If you look at the network utilization, you can also see that when we triggered storage migration, the network bandwidth, the network utilization also went up. So the good part about this unified view is that you can look at a graph and you can spot anomalies. You can spot if something doesn't look right. You can spot patterns. You can look at, you can see if you see something which you do not expect, you can go ahead and investigate it. This is the PCS summary page. It's again a snip from PCS run. On the left side, you see all the resources which are participating in this particular run. So we had 31 nodes. We have 4 storage nodes and around 500 virtual roles which are running. On the right side, we list down all the operations that happened on these resources. So you can see that we have VM live migrations, we have storage migrations, compute node restart, bug check node, which is unplanned node failover. We also do actions against storage nodes. So this gives you overall summary. You can, when you are having a PCS run going on, you can go to this page, look at this and figure out and see what is going on at this exact moment. And all this data is updated live. Execution requirement. So PCS needs one controller node. Actually, let's go back to the earlier slides to. So PCS needs a couple of management nodes from where it effectively execute and derive traffic. It needs the cloud, the compute and the storage resources which you are exercising your scenarios against. And it needs a SQL database where all the data will be logged. So that's pretty much about this execution requirement. You can, for the shared storage, you can have local CSVs or you can have scale-out file servers. You can, for the shared storage, you can have local
Any
CSVs
questions?
or you can have scale-out file servers. Any questions?
No questions?
Okay. So that's about PCS. If you have any questions, please feel, I will be around. Please feel free to ask me. You can ask Son, who will also be around, any questions you have. Thank you.